This is the fourth in a series of resources that look at matrix algebra. We define and provide basic information about matrices. We consider the operations that allow us to manipulate matrices. We discover how to use the row operations to solve a system of equations using matrices. We consider various operations on pairs of matrices, including adding, subtracting, linear combinations, and multiplying. We learn how to find the inverse for a matrix. We discover the determinant for matrices and learn how determinants allow us to solve systems using Cramer's rule. In order to perform basic mathematical operations on matrices, they must meet criteria regarding their dimensions. When adding and subtracting matrices, they must have exactly the same dimensions. If they do, adding or subtracting matrices is relatively simple. We simply match up position by position and combine the elements appropriately, either adding them or subtracting them. Let's look at an example. Suppose we have matrix A equal to 5, 4, and 3, then 2, 1, and 9, then 8, 7, and 6. We also have matrix B equal to 9, 1, and 3, then 5, 8, and 7, then 6, 4, and 2. We will attempt to add and subtract matrix A and matrix B. First, let's add matrix A and matrix B. We match up position by position and add the elements. So we have 5 plus 9, 4 plus 1, and 3 plus 3. Then 2 plus 5, 1 plus 8, 9 plus 7, then 8 plus 6, 7 plus 4, and 6 plus 2. Completing the calculations, we have A plus B equal to 14, 5, and 6, then 7, 9, and 16, then 14, 11, and 8. What if we want to subtract matrix B from matrix A? We do much the same thing as when we added them, except we subtract. We have 5 minus 9, 4 minus 1, 3 minus 3, then 2 minus 5, 1 minus 8, and 9 minus 7. Then 8 minus 6, 7 minus 4, and 6 minus 2. When we do the math, we find that matrix A minus matrix B is equal to negative 4, 3, and 0, then negative 3, negative 7, and 2, then 2, 3, and 4. Are there other basic mathematical operations that we can do with matrices? Yes, there are. We can also do scalar multiplication. Much like we did scalar multiplication as a row operation, when we have a scalar multiplied by a matrix, we multiply each element in the matrix by the non-zero constant. Suppose matrix A is equal to 5, 4, and 3, then 2, 1, and 9, then 8, 7, and 6. We want to find 5 multiplied by matrix A. To do so, we simply multiply each number in the matrix by 5. So 5A equals 25, 20, and 15, then 10, 5, and 45, then 40, 35, and 30. We can combine the ideas of adding matrices and performing scalar multiplication to find linear combinations of matrices. How does this work? First, we need to do the various scalar multiplications. We finish by adding the resulting matrices. Let's see an example. Suppose we have A equal to 5, 4, and 3, then 2, 1, and 9, then 8, 7, and 6. We also have matrix B equal to 9, 1, and 3, then 5, 8, and 7, then 6, 4, and 2. We want to find 5A minus 3B. Multiplying each element in matrix A by 5, we get 25, 20, and 15, then 10, 5, and 45, then 40, 35, and 30. When we multiply each number in matrix B by 3, we get a matrix of 27, 3, and 9, then 15, 24, and 21, then 18, 12, and 6. Now we can do the subtraction of the two matrices. We have 25 minus 27, 20 minus 3, and 15 minus 9, then 10 minus 15, 5 minus 24, and 45 minus 21, then 40 minus 18, 35 minus 12, and 30 minus 6. Completing these subtractions, we find that 5A minus 3B equals negative 2, 17, and 6, then negative 5, negative 19, and 24, then 22, 23, and 24.